Okay, great. So let's get started. So I hope everyone can hear me. If anybody cannot hear me, just let me know on the chat. And I hope all of you can also see the shared desktop showing the slides and as well as my webcam video. Okay. So we'll start with a recap of class 2. And so as we did for the first class, I just want to go around everyone, and I want all of you to tell me a couple of points that you remember from class number 2. So tell me, so please type in your whatever the key points that you remember from class 2 on the chat window. So we discussed I think three main topics. One was EC2, then we discussed AMIs and networking for EC2. Right, Rajendran, we can bind elastic IPs to any EC2 instance within our account. And what's the difference between elastic IPs and normal public IP addresses? Spot instances, yes, Aditya. So what are spot instances? Okay, Abhijit, can you tell me some benefits of server virtualization? Yes, Abhi, the instances we can get for our spot instances. Yes, Rajendran, very absolutely right. So elastic IP addresses are like static IP addresses. Uh, I don't know what you mean by they can be shared with others. Like if you mean that we can host, we can put that we can use that IP address as a static IP address and map our DNS to that static IP. Then you're right. But uh, if you mean something else by shared with others, then I would definitely like to know. Ankit, elastic IPs can be mapped to individual interfaces. Yes, they can be mapped to individual EC2s. Now, till now we've only discussed what's called EC2 Classic, which is these are public EC2 machines. They are accessible from the internet. There's another type of EC2 called VPC, Virtual Private Cloud, which is Amazon's implementation of private cloud. Uh, so in EC2 Classic, the any machine can have at most one public IP address. So it's not really the case that there are multiple interfaces. So it's actually elastic IPs can be mapped to individual EC2s, private IPs and public IPs. Yes. So private IPs are essentially routable within a region, and public IPs are routable from anywhere on the internet. So if you want to communicate between EC2s in the same region, which IP can you use? And if you want to communicate between EC2s in let's say two different regions, which IP should you use? Yes. So in within a region, we can use either private or public. Private is better because it's cheaper. Uh, we can. Look at the AWS pricing. Using private IP addresses is cheaper than public IP addresses, and in the latter, we can only use public IP addresses to communicate between two EC2 instances across, in two different regions. Yes, Abhijit. So using server virtualization, applications are more isolated from each other. Are they completely isolated? So let's say within one physical server, I have two virtual servers, each of them running one application. So are they uh, so we discussed these three models, right? Where one was where there were one application per physical server, then another model where there was multiple applications for one physical server, and then with server virtualization we can have multiple applications on a guest OS and then multiple guest OSs on a physical server. So which of these have the best isolation? Multi-tenancy, yes. So what is multi-tenancy, and what are the benefits of multi-tenancy and what are the challenges with multi-tenancy? Yeah, complete isolation means no sharing of data. So data is just one resource. Also, it means no sharing of any physical resource. So or as little sharing of any physical resource as possible. So for example, CPU, memory, storage, disks, even the network. Yeah, security. Okay. I think nobody talked about AMI. Can somebody share a couple of points, something that you remember about AMI? Yeah, they are pre-configured images from Amazon. Okay, can it be only from Amazon? Who can create AMI? Yes, Aditya, Abhi, both right. Rajendran, all of you are right. So anybody can go and create AMI, and I think we also discussed that there's something called the AWS Marketplace where uh, third-party providers share their AMIs either for free or for a price. And in fact, we can create our own AMIs and just use it for just our account, or we can share it publicly with anyone as well. Okay, so I think that's good. Anything else that you want to add from any of the previous two classes? Anything that you want me to discuss before we go on to any new topics today? Okay, so then I think that there are a couple of things that I wanted to discuss regarding the quizzes. Okay, let me mute Avinash's line. Okay, so quiz number one. I think thank you all of you, except one of you. Everybody has taken quiz number one, and so anything that you want to discuss regarding quiz number one, let me know. Either I think it's been some time, so what I'll suggest is we can discuss on the forum if that's okay, or if it's something important we can discuss in the class as well. Now let me see quiz number two. Let me see how many of you have taken quiz number two. Yes, Abhi. So unfortunately, I was supposed to cover the storage in class number 2, but I wasn't. So okay, you have paused uh, quiz number 2. That is fine. So what I see is that five of you have taken quiz number 2, which is fine. Uh, and so if Abhi and anybody else who has paused the quiz because there were some topics, questions from some topics that we've not yet covered, that is fine. But definitely, I want that you guys should complete quiz number 2 by the end of today. So is that can I have agreement on that? Can all of you please commit to completing quiz number 2 by the end of today? What about the other people? Abhi, Hidayat, thank you. Abhijit, thank you very much. Aditya has already done it. Right. Okay. Uh, Ankit, what about you? Have you taken the quiz? Okay. Rajendran has also done it. That's right. Priyaranjan has also done it. That's right. So please, I'm just requesting you that whoever has not taken the quiz, please take it at the end of today's class. Okay, because by the end of today's class, we will actually be on quiz number 3. So we don't, I really don't want you to have a backlog uh, in terms of these quizzes and assignments. We should just uh, the main purpose of the quiz is to reinforce the learning covered in that class, and so it's best if you take the quiz immediately after the class. And I'm sorry, it was my mistake in quiz number 2 because we couldn't complete some of the topics. So sorry about that. Okay, next thing, assignments. So let me just check how many of you have taken the assignment. Okay, I see 3 assignments have been submitted, and so 2 of you have submitted assignment number 1, and 1 of you has submitted assignment number 2. Right? So this is not acceptable, basically. So I mean, so I just want to hear from you guys. Why haven't you guys done assignment number 1? What are the problems you're facing, and anything I can help with. But basically, as I want to re-emphasize again and again that this course is not about me giving these lectures. That is not the way you will benefit from this course. Rather, it's about you going out there and trying to do these quizzes, assignments on your own. So I'm not gonna leave you off the hook on the assignment. So you have to do all the assignments and do them, put your reasonable effort there. So please tell me, why haven't you guys, except two of you, uh, nobody else has completed assignment number one. Can you hear me? Okay, Ankit, you sent me a private message. So I think what you are referring to is assignment number two, right? I think you're referring to assignment number two, but why haven't you completed assignment number one? Yeah, so assignment number one was, there were two questions. One was to write a short article on the current the latest trends on cloud computing, and you could take any aspect of cloud computing. But this was supposed to. Okay, another thing before assignment number one, have you guys, or who of you have? Okay, I think I had shared some 4 or 5 articles in the first class. So how many articles have you read so far out of those 5? But I would like everyone, each of you, to respond to that. So how many articles have you read from the reading list shared for class 1? So I think I had shared 6 articles, and I think all of those articles are really good. They give you a good sense of some of the important aspects of cloud computing and underlying technologies such as server virtualization. So can I get some answers? I mean, I've got a couple of answers, but Aditya, Ankit, Avinash, Hidayat, Priyaranjan, Rajendran, what's your status on this reading these articles? Have you even tried to open these articles and even just skim it or read maybe the first page or so? Okay, so Rajendran and Ankit. So I think those were different things. I'm talking about the reading material shared on the learning management system for class 1. So things like virtualization, blessing of curse, computing in the clouds, virtualization overview, a view of cloud computing, and beyond server virtualization. Okay, very good, Abhi. If you're reading EC2 and its facts, great. That's something that all of you should do, and very good that you started on that. I think that's a very good source of information. Okay, Avinash, when are you going to get to them? Because now, so what will happen now is we are going to get more into the AWS specific things, and we are also going to power on a little bit in terms of the speed that we are going at. So if you continue to have a backlog on the things that we've discussed in the previous classes, uh, you'll have a burden on your shoulders at that time, and you'll not be able to cope with it, and you'll essentially, I think, you'll just lose out on a lot of the good learning in this course. So I just want to request you that we should not let's not have a big backlog. Yeah, Rajendran, I would really request you to check them out today. Uh, just, and you don't have to read it uh, very, like, you don't have to review these articles. It's just if you can just skim through them, understand some of the main points that the article is trying to make. So by the way, we've already discussed the key points of these articles in those classes, but obviously these articles are more detailed, and so at least I would request all of you to skim through all of these 5 articles in today or tomorrow, but within the next couple of days, because now I hope you can see that you guys have a backlog uh, building up. So you have to do assignment number 1, you have to do assignment number 2, then I think assignment number 3 also is out. So I think so assignment number 3 is also due on this week, the coming week, Wednesday, right? And yeah, assignment number 2 is due on Saturday, but so at least assignment, I would like you to start making progress on these assignments. And I'm okay, if some of you feel that assignment number 1 is you need to do a little more research on that, I am okay if you shuffle the order. So you can do assignment number 2 before assignment number 1. That's okay. But assignment number 3, I want you to do it by Wednesday, because at the end of this class you get another assignment. So you don't want to have this backlog building up. And assignment number 3 is basically a hands-on uh, practice assignment on the AWS console. So I think it should be a lot of you were not, it should be a lot more fun. Okay, Abhi, you couldn't find the EC2 assignment, so look at the module called, okay, let me just send you the link. So I just sent you the, shared with all of you the link for assignment number 3, which is essentially, it will get you to execute some of the common use cases or common things that we do with EC2. Okay, so anything that I can help with to ensure that you guys don't continue to build up this backlog on assignments, because if otherwise, if you're going to sign up for these assignments, then I would like to adhere to the timelines that we have agreed upon. So especially for assignment number 3, the due date is Wednesday 11th December. So is that okay for all of you? Aditya, Avinash, Hidayat, Rajendran, what do you guys think? Will you be able to get to it? I think it should be fun, because this is the first assignment where you will actually be playing around with the AWS things on your own. So I want to make sure that this week we sign up for at least couple of things. Okay, Aditya, have you uploaded? Okay, so Aditya and all of you, if you're done with the assignment, just let me know that you're done with it, so I can go into the AWS console and check it out. And you can just signal me using by sending me an email, or by, better by sending, by submitting a short document, or like let's say a text file which says that, it could just be a dummy text file where you just upload it to the assignment. Because when you upload it to the assignment, the learning management system will set the status as submitted, and I'll get to know about it. So yeah, better than email, just submit a empty document for assignment number 3 on the learning management system. Okay. So by this week, at least, what we want to do is finish assignment number 3, which is on EC2, and then finish at least part of assignment number 1 and 2. I realize that assignment number 1 may take, requires a little bit of research and, a little bit of preparing the analysis and all. So it's okay. If you want to take a little more time, assignment number 1, that's fine. But at least finish part of assignment number 1 and 2 combined by the end of this week. So it does everybody, is there anybody who doesn't agree with that? Please let me know now. Otherwise, I will strictly adhere to that, to this, to these agreed upon deadlines. Okay, so I think everybody agrees to that. I'll also send out, our agreement on email to remind, both of us what we agreed upon. Okay, so with this, I think that was the recap. Now let's get started on what I wanted to do today. Yes, Abhi. Assignment number 1 depends on AWS pricing. Right. So, but again, what I'm requesting is that I know assignment number 1 we will not be accurate. So you can just go to the AWS pricing page, which I'll just share a link on that. So just share the link for the AWS pricing page, and just take one of the select one of those instances. Like you can select all Linux medium instances or all Windows medium instances. So just assume a particular type of instance. Don't try to complicate things by using multiple types of instances, and use that for your analysis. So basically, I want something simple. We should try to keep it simple, uh, because if we try to complicate it, it can be, there's no end to the second question of assignment number 1. It can be made as detailed and as complicated as we want, and there's absolutely no end to it. So just a suggestion is that you can keep it simple. But from my perspective, I want you guys to just go through that exercise of listing down the different components of a data center cost, and just comparing of like a ballpark comparison of the cost to build our own data center versus using Amazon for hosting our servers. Okay, so today we're going to start with the AWS storage services. So this was a topic that I was supposed to uh, do in the previous class, but we couldn't get to it. But this is a very, very important topic, because simply because it's storage is uh, something that is the right kind of storage to use depends a lot on our requirements of the use case or of the workload. And AWS offers quite a variety of options, the storage services that we can use. So because of that, I think this the topic is very relevant, and please make sure that you understand the different storage options that we discussed well. At least at a at a fundamental level, you should understand the differences between those options. So we're going to discuss three types of storage options provided by AWS, and the first one is called instant store, and it's also known as ephemeral storage. So what is instant store? It's basically block level temporary storage for EC2 instances. So block level means it has a block device interface. It appears like a hard disk for your EC2, and this kind of storage is attached to the EC2 instance. We'll see what temporary means on the next slide. Then this storage is essentially being served from disk physically attached to the physical server on which the EC2 VM is running. So I'll just show you a diagram of that. So this is the diagram of physical server in AWS, and we see that this server has two EC2 instances A and B running on them, and it also shows 4 volumes, and these volumes or these disks are physically attached to the physical host. Okay, so if you know something about, if you've heard network attached storage or storage area network, the NAS plan, or something called direct attached storage. So this ephemeral is direct attached storage. It's basically the disks are attached to the physical server via direct cabling. This is not network attached storage, and this is not storage area network. Okay, now because of this, now here's what happens. So we know that instances can be stopped and restarted. Okay, now what do you think happens when I stop and let's say I stop instance A and I start it again? Do you think that this instance will run on the same physical host every time it stopped and restarted? So for example, I can stop the instance today and I may just restart it tomorrow. So when I restart it tomorrow, what are the chances that it will get started on the same physical host? Did you guys understand my question? So basically these instances are virtual machines, right? And I can stop them, restart them. So I stop an instance and then restart it after some time. That some time could be hours, minutes, days, whatever. Now when I restart that instance, will that instance be restarted from the same physical host, or could it be some other physical host? Right, Priyaranjan and Aditya, absolutely right. So the physical host, uh, we cannot guarantee that it will be the same, and it might change. In fact, it's more likely to change because the kind of setup that AWS has, where there are thousands of physical hosts, once instance 8 stops, there's a good likelihood that there could be another instance C that starts running on this host. So the next time instance A runs, it'll get some other free physical host. Okay, so now let's say A started on some other physical host. So what is the impact on the ephemeral storage that was attached to A? So the ephemeral storage was built out of disks that are attached to physical host number 1. yeah, the storage will get disconnected, or basically those disks are no longer connected to A, because those disks were connected to physical host number 1, but when A was restarted, it was restarted on physical host number 2. So those disks are no longer connected to A. So that's what ephemeral or instant store, that's the kind of the main property of this, that there is no persistence of instant store across a EC2 stop. So the data will be lost. Absolutely right, Ankit. Right. So no persistent, which means that all the data, basically your entire instant store volume will disappear when an EC2 instance is stopped. Yes, Abhi. This is how we get that location independent, the decoupling between virtual machines and physical servers. Yes. So um, so is this point clear, that uh, the instance store does not persist across the stop event? So please make sure this is the most important point of instance. Excuse me. So this is the most important point about instance store or ephemeral volume. So please, can I have a heads up, yes or no, from all of you? Is that clear? Uh, what this means and why this is happening? Okay, Hidayat. Okay, Aditya. Let's not. It's a good question. This is overcome by the next kind of storage service that we'll see. So just hold on to that question. Uh, for now, let's just try to understand what is instant store, and yeah, this is like a shortcoming or a challenge with instant store, but that's fine. Let's try to understand it. Okay, a second aspect of instant store is that the data is not durable. So durable means that uh, what is the chance that the data can get lost? And essentially, instant store volumes are built out of disks that are directly attached to the physical server, and those disks can get corrupted, they can crash, they can have hardware problems, firmware problems, things like that. So instant store volumes, there is essentially no way to recover from those kind of events, because there are no replicas of instant store volumes, there are no snapshots, no backup. Uh, yes, the application can do its own backup if it wants to, but at least in terms of the infrastructure that Amazon provides, there is no way to, it doesn't provide any sort of backup service for instance store volume. Yes, Abhijit, good observation. We'll understand in a couple of slides how that happens. Yes, instance store disks can have RAID also. It's I've mentioned that somewhere. So given that instance store volumes are non-persistent, what are the use cases for this? It's basically the use cases where persistence of the data is not important. So for something like scratch disk, so you have some temporary data or files, caches that you want a place to store them, or you have data that can be easily replicated or recreated every time the machine starts. So those are the use cases where you can use instance store volume. But any use case where you need persistence of the data across a machine stock, you cannot use instance store volume. For that, you have to use something called EBS, Elastic Block Storage, which we'll cover in the next after a couple of slides. Okay, okay, very important to understand. So, what are the anti-patterns for instance store volumes, or basically the use cases where instance store volumes cannot be used? So anywhere where the data is valuable and long term, databases. So databases by definition are something that you know they are long term and they are valuable data. Shared storage. So I'll come to shared storage a little later. Anywhere we need snapshots. So because instance store volumes don't have backups for snapshots, so we can't use that. So basically anywhere we need persistent storage, we cannot use instance store volume. Now we can use instance store volumes as the root volume, but as a best practice, I will unless your use case is you're sure that your use case is such that it doesn't require persistence of the root volume. So unless you're absolutely sure, I will recommend that you do not use instance store as the root volume, because if the root volume, for example, any package that you install, that will get installed on the root volume. So every time you restart a machine, those installed packages will get lost. So as a best practice, do not use instance store volume as the root volume. Instead, use EBS volume. Okay, instance store sizes. So the number and size of instance store volumes varies by the EC2 instance type. So I'll show you what this means. And larger instances have larger volumes. So basically, there's this table which shows the kind of instance store volumes that are attached to a particular instance type. So you can see that the first three don't have any instance store volume, but let's say m1 dot small. M1 dot small comes with one instance store volume of 160 gigabytes. Then there are some EC2 instance types where there are 2 volumes, 4 volumes, so on. There are also the cases, the last two in this list, they come with a SSD backed instance store volume. So that is also possible. Now the key thing is, what is the price of instance store volume? It is included in the price of EC2. So essentially what this means is that you kind of get it for free. Now, or it's basically included. Now it's up to you. If you don't want to use it, Amazon will not reduce the EC2 price for you. And if you want to use it, go ahead. It's already included in the EC2 price. So abhi, it is a standard volume. So it will be mounted at wherever wherever the volume is mounted in that EMI. And actually for different kind of operating systems and different kind of EMIs, the mount point is different. So let's talk about the root volume. So for Windows, the root volume will be C colon, but for I think we saw for this one Ubuntu, it was something like /dev hd something. hd some x. Sorry, it was so something like that, but it will be this whatever mount point. It doesn't. It'll not be any different from a regular, from any other volume. And so this is the device name. Now where you mount it is completely up to your choice. So the device name will be something /dev hda or hdx, something like that, and then you can mount it anywhere in the file system that you want. Of course, if you have a instance, if you have a EC2 where the root volume is an instance store volume, then it will be mounted at flash. Okay, a couple of other properties about instance store. They cannot be detached and then attached to another instance, right? Because instance store volumes belong to the physical host. So we cannot assume that two EC2s will be running on the same physical host. So because of that, there is no concept of detaching an instance store volume from EC2 one and then moving it to EC2 number 2. And these can also be used to create a RAID group. So for the cases where an EC2 instance comes with multiple instance store volume, you can connect them together in a RAID group. For example, you can striping RAID group to increase performance. Okay, and instance store performance is so this slide is actually it's talking about uh, the magnetic disk based instance store volumes. It's not really referring to the SSD based instance store volumes, but basically instance store volumes are not optimized for high performance, and specifically they are good for sequential IO, but they are very poor at random IO performance. Yeah, Aditya, absolutely. So you can browse. So an instance store volume will appear as a standard partition on your EC2 instance. So you can mount it on your EC2 instance and then just navigate the directory. Just navigate it as a mount point, and you can create data, read data, anything on it. But the key point is that after you stop and start the EC2 instance, your instance for anything that you stored on the instance for volume will get deleted. Okay, now another important point about stop and start is, so there's a difference between stop and start versus a reboot. Okay, because a reboot just reboots the virtual machine on the same physical host. So the instance store data is not lost during a reboot. Is that clear? Difference between, so there's a difference between reboot and stop start. Okay, I hope everyone got, yeah, there's a difference between reboot and stop start, because reboot will happen on the same physical host, but stop start, basically when you restart the machine, it could be on a different physical host. Abhi, so stop is akin to pulling the plug out. Yeah, you can say that. So stop is equivalent to powering off the machine. Okay, so here's the self-practice assignment. If you want, we can also do it as a demo, but I would really want you guys to do this assignment, and if you have any problems, I'll be more than happy to help you out with it. But essentially, I want you guys to create an EC2 instance with an instance stored root volume. Uh, so okay, I can show you a demo, but uh, this is very easy. So let me just show you a part of it. Okay, not show you the whole thing. Then after you created that EC2 instance, you write some data to the root volume. Then you do these two use cases. So in one use case, you reboot the EC2 and then you verify that your data is still there. In the second case, you stop and start the EC2 and then you verify that your data is gone. Okay, and I'll just show you uh, how to say on the AWS console that you want an EC2 instance with an instance store volume. Okay, can you guys see this my AWS console? Just any one of you can. Okay, just loading up. Okay, great. So I'm going to launch an EC2 instance. So we've already seen this, but last time we did it. I just skipped over the point of where we selected the volume, and but this is the time to know about it. Okay, so we cannot use a micro because remember that micro does not have any instance store volume. So let's use a small. Okay, so you can see here so look at this column called instance store. It shows that this instance will have one volume of 150 gigabytes. Right. So sorry, one second. Yeah. So I'm going to select small, then I'll just go to next. So all these things are fine. Number of instances, network, IAM, shutdown, all these things are fine. Now, okay, since we are here, let me just tell you about shutdown behavior. Shutdown behavior basically means what do you want to happen when the machine shuts down, and there are two options. By default, the machine will just stop, which means that you can start it again, and then the other option is that it will terminate, means in any shutdown will just terminate the machine, and terminate basically means it just it just goes away from Amazon. Okay, so the next step is the main one, this add storage. So okay, so one second. So actually, Amazon is no longer, so it's not giving any option to create a. Okay, one second, Abhi. We'll just check out what Abhi is saying. Abhi, where is that? Which page are you referring to for the device name? I think it's the next one. Right? Yeah, this one. So, hey, just one second, guys. One second. Okay, sorry guys for that distraction. Yes, Abhi, Ankit, it is AMI specific. So obviously it's going to be different for Windows and Linux, but also it's different for different AMIs. And since we are talking about it, let's look at that. So I'm going to choose a different AMI. So this I'm going to choose the Amazon Linux. Okay. And again I'll just choose a small. Okay, my instance details are fine. Okay, so again in this case is the same /dev SDA1 SDA1. But okay, so what I was trying to get to is that Amazon is no longer allowing us to create EC2 instance with the instance store root volume using this way, but we can do it in some other ways. For now, what you can just do is add a new volume and set the type as instance store. Okay, and that's it. So this will add. When we create this EC2 instance, we'll have two volumes. The root volume will be EBS, and the second one, flash dev SDB, will be the instance store volume. Right, which we can see here, and it's also called ephemeral, that I already shared with you. Let's launch it. Aditya, Aditya, I don't think so. I don't think we can create uh, further partitions on these volumes. But if you're familiar with the fdisk, you can try it out. But I remember I trying it out, looking at these volumes using fdisk, and I don't think it's possible to create further partitions, because to create further partitions you need something called the partition should be an extended type partition, and these are not extended. These are either logical or physical partitions. Okay, so I don't know much about LPM, so maybe what else this is, try it out, and let all of us know about it. But I don't think it's possible. So anyways, let's just we can try to log in into this machine. Yeah, it'll take a little bit of time, because my Linux machine is just coming up. So we'll get to this in a minute or so. Fine. Okay. But this is an assignment that I want all of you to do. Okay, and then we'll talk about Elastic Block Store. So, like instance store volume, Elastic Block Store is also block level storage, which means it appears as a disk attached to your EC2 instance. But the key difference between EBS and instance store is that EBS is persistent storage, and its data lifetime, basically the lifetime of an EBS is independent of the lifetime of the EC2 instance. Which means, for example, I can terminate the EC2 instance but still keep the EBS volume around, which I cannot do with instance store. And I hope that point is clear to all of you. Okay, now if you're familiar with basically block devices or hard disk, any individual EBS can only be attached to a single EC2 instance. So this is what I meant by shared and not shared storage. So EBS and instance store are both non-shared storages, because they are block devices, and a block device can only be attached to a single device at any particular time of any particular time. So that and we'll see an example of shared storage also after 10 minutes. But basically both EBS and instance store are block devices, they can only be attached to one controlling device, or basically one controlling EC2 instance at any particular point of time. Now with EBS, we can detach it from one instance and move it to another instance, which we were not able to do with instance store. Okay, to answer Abhi's question, the last point, EBS is network attached storage, which essentially means that this storage is not served from disks attached to the physical host. Rather, disk storage is served from a storage appliance sitting somewhere else in the network. Basically sitting on some other hardware, not on the same physical host. So I know I don't want to go into details of network attached storage and all, but basically as a concept, I hope you understand it. So direct attached storage is where the disks are attached directly to the physical server, whereas network attached storage is where these disks are attached to a second physical server, and then the storage is basically accessed over a network. Yeah, Aditya will come to that. But is this at least conceptually, do you guys understand network attached storage? If you want, I'll share some reading material on some basics about these storage things called NAS, SAN, and DAS. But at least conceptually, do you understand the difference between storage, direct attached storage and network attached storage? Anyone has doubts on this? Ankit, Hidayat, Priyaranjan, Rajendran. Any confusions on what we've discussed so far? Okay, good. So now because it's network attached storage, now let's talk about the use case that we were talking about earlier. So I have a just give me a second. I think there's a picture for this. Yeah. So basically, this is a diagrammatic representation of EBS volume. So on the left side is our physical host for EC2, and on the right side is our physical storage host. So this is like this is also a physical server, but it doesn't run EC2s. Rather, this physical the physical host on the right side is a special server that only does storage, and basically the volumes or the disks are attached directly to the physical host on the right side, and it is served to the EC2 instances via the network. And then this diagram also shows some of the device, sample device names that appear in the EC2 instance. No, right side is not like a backup. So okay, to simplify things, just think that the right side is a separate physical host. It's a separate server, separate physical server. Now, just the difference between the left physical server and the right physical server is that the left physical server is its purpose is to host EC2 virtual machine, whereas the right physical server, its purpose is to host storage volumes. So these are these two types of servers have different purposes in their life. Okay, and I think if you have any specific, still have like any doubts or confusion on this, please discuss on the forum, because beyond this, I think we're getting into too much storage, which I don't want to do here. But I will share links on basic storage concepts like DAS, NAS, and SAN with all of you. Okay, now let's talk about this case that So we have this EC2 instance and then we stop and start it. So when we start it, it could run on a different physical host. Okay. So would do you see any problems in these volumes, in these EBS volumes still being accessible even if the EC2 instance is run from a different physical host? Okay, so the question is that when we stop and start the EC2 instance, it could end up being on a different physical host. So with instance store volumes, we had the problem that because it was on a different physical host, those instance store volumes were no longer accessible. But what do you think about EBS volume? So even if the EC2 goes on a different physical host, uh, do you think that these EBS volumes will still be accessible from our EC2 instance? Yeah, they can be attached again, or they are already attached because basically EBS volumes are accessed over the network, and as long as we give the network, as long as we give all those informations like the volume name, server name correctly, as long as we configure it properly, those the EBS volumes will continue to be attached to our EC2 instance. Yeah, this is uh, something conceptually. Yeah, NFS, you can relate it to NFS, like uh, although NFS is at the level of it's within an operating system, whereas these volumes we are talking about at the virtual machine level. The connection to these volumes is established by the virtualization software. Right, something similar. Okay, so because of this, basically EBS is persistent across EC2 stop start event, and the typical EBS use cases are anything that requires persistent storage. So for example, databases, root volume. So most of your typical use cases for storing data, where you need persistence of the data for across stop events on the machine. Okay. Here are some properties about EBS volumes. So they are designed to be highly available and reliable. So which basically means that Amazon takes certain steps to uh, make sure that EBS volumes uh, have a high degree of availability. Now the high degree of availability is beyond uh, it's beyond the physical uh, okay. So basically it means so Amazon replicates these EBS volumes within a region, so that so let's say for example our EBS volume consists of two disks, and disks have a very high failure rate, but Amazon will replicate the EBS volume uh, in two places, so that even if one set of disks fails, there's another one which are ready to serve the data. And EBS volumes, the second point is that EBS volumes are attached to a specific availability zone. So, couple of points here. One is that an EC2 instance can only uh, basically for an EC2 instance, it's the EBS volumes that are attached to it must be in the same availability zone as the EC2 instance. So you cannot have a situation where my EC2 is in availability zone A, but my EBS is in availability zone B. So you cannot have that situation. Second, EBS is mirrored or replicated within a single availability zone, which improves the availability and reliability of the data. But on the downside, it means that if that availability zone has some kind of disruption, for example, a power failure or something major that just takes that availability zone out, then your EBS volume will not be available. And in fact, there was a big outage in Amazon, around this specific thing in December 2012, and this was around Christmas Eve. I think I talked about it in one of the earlier classes where Netflix was badly affected. So their streaming of movies over the internet, their service was badly affected because their EBS volumes uh, became unavailable because a single availability zone, one of the availability zones in the North Virginia data center, North Virginia region, had some kind of hardware problem. Okay, then the EBS sizes can range from 1 gigabyte to 1 terabyte, and like instance store volumes, they can also be used to create a RAID group. So I can attach 4 EBS volumes to a single EC2 machine and group them together in a RAID 0 group, for example. Okay, so before we go on to the next slide, any questions so far? Are you guys able to follow at least the key points that we've discussed so far? Any doubt? Anyone? Okay, regarding this availability of EBS volume, I was trying to pull up the number, but I was just unable to. But I think the EBS volumes are their availability characteristic is something like 99.95% uptime, which 99.95, or I think it's 99.5% uptime, which is something like yeah, just one second. Yeah, so 99.5% uptime is 5 hours for 1000 hours. That's right, Abhi. So, but in terms of years, it means roughly 44 hours, 44 hours in a year. So maximum, but I'm not like sure of this 99.95, 99.5. So I will give me a little bit of time. I'll just research the correct number and share that with you. Okay. Now next, we want to talk about this very important feature of EBS called snapshot. So snapshots is a standard term in the storage industry, and it basically means that it's a point-in-time copy of the volume or of the data. So just make sure you understand this: point-in-time copy of the volume. So there's this volume, and this volume is has data being written to it. So I take I kind of freeze the volume at a particular time and just take a snapshot of the data uh, in that volume at that particular time. And snapshots are great because they can be used for backup, and more than that, they are also great because they are incremental. So incremental means that let's say um, my volume is 100 gigabytes, and I'm changing 10% every day. So basically, 10 gigabyte is being changed every day. So my first snapshot will be 100 gigabytes, and my second snapshot and after that will be only be 10 gigabytes each. Basically, the snapshot each snapshot will only uh, take the amount of space corresponding to the change in the volume. Okay, Ankit, can we take the snapshot of a volume and sell it as an AMI? So a snapshot and AMI are two uh, different things. They are related, but they are also different. So an AMI is a machine image. So basically it's a bootable image of a an image that can boot an EC2 instance. Versus a snapshot could just be, for example, you may have a volume uh, that has only data and you can take a snapshot of it. But to answer your question, the answer is yes. So uh, and if we want, we can see a demo of that. But basically, we can create an AMI from a snapshot. So the sequence of events is something like I create an EC2 instance and configure it to my requirements. Then I take a snapshot of the EC2 instance, or more specifically, a snapshot of the root volume, and then from that snapshot I can create an AMI and then sell it or share it with anyone. Okay, so incremental. So let's make sure we got this. So snapshots only capture the data that is different from the previous snapshot. So let's take another case, that let's say I have 100 GB of data and 10% new data is being added every day. So my machine starts out at 100 GB, then next day it becomes 110, then after that it becomes 110 plus 11. Okay, then after that the next day it becomes 121 plus 12.1. Okay, in this case, when I take a snapshot, the first snapshot will be 100 GB, but the next snapshot will be S0 will be 100 GB. Then the second snapshot, or S1 will be 110 minus 100, only the difference. So it will only be 10 GB. S2 will only be 11 GB, and S3 will be 12.1 GB. So these snapshots are space efficient. So and they can be used for space efficient backup. And then as Ankit said, there are few other use cases with snapshots that will come to in just a minute. Okay, then another very important thing to note about snapshots is that they are stored in S3. We'll talk about S3. S3 stands for Simple Storage Service, and we'll talk about that next. And an attribute of S3 is that it is much more highly available and durable than EBS, because the data stored in S3 is replicated across replicated in multiple availability zones, whereas the data stored in EDS is only replicated within the availability zone. So this is what so we can do. So we can attach an instance store volume and an EBS volume to an EC2 instance, and but we can also snapshot an EBS volume, and this snapshot is stored on S3. So we'll get to S3 in a few minutes, but just for now, just understand that these are stored in S3, because you need to understand, like if I take a snapshot of EBS, where would you store it? Would you store it in another EBS volume, or where? So the answer is that no, it's not stored in another EBS volume. The snapshot is actually stored in another storage service called S3. Okay, and here are some use cases with snapshot. So we can create EBS volumes from snapshot. So this can be, for example, this can be used to copy EBS volume. So I have one gold image EBS volume. I create a snapshot of it, and then I can create 100 more EBS volumes that are from that snapshot. Then we can copy snapshots across regions. So for example, I want to copy my volume from North Virginia to Singapore. So I'll not be able to copy the volume. I have to first snapshot it, then copy it to Singapore, and then from that snapshot create a volume in Singapore. Make sense? So can one of you, or can all of you tell me what are the steps to copy a volume from region 1 to region 2? Can I create a volume with S1? Yes. So a very good question from Abhi. So I think what Abhi is getting to is that we created all these snapshots, and only the first one is a full, it takes the full space, and all the other ones have only incremental space. So the snapshots are space efficient. Now I think what Abhi is getting to is that let's say we delete S0, which is the base snapshot. Then what will happen? So the answer is that even if we can use any of these individual snapshots to create a volume. And that's how the snapshotting technology has been implemented in AWS, that although these snapshots only take incremental space, but when I say create a volume from S1, logically what it will do is that it will create a volume from the combination of S0 and S1. So it'll kind of do it'll apply the base snapshot first, and then on top of it, it will apply the incremental snapshots. And if I delete S0, then it will the snapshot will reorganize themselves to make sure that the base snapshot still exists. Basically, even if I delete S0, I can still create volumes from S1, S2, and S3. Confused, or am I making sense? Do you understand what I'm talking about? So yes, Abhi, when we delete S0, yes, Abhijit, very right. So Abhijit has listed the correct sequence of steps to copy a volume from region 1 to region 2. So can you please all of you look at Abhijit's sequence? Yes, Abhi, S1 takes S0 space, correct. So logically something like that happens. exactly, I also don't know, but we can do this demo, or you guys can do this self assignment where you take these snapshots and see what happens when you delete the base snapshot. But something like that will happen. What you said, that S1 will now become the base snapshot. It will take S0 space as the base snapshot. Yes, and S1 will get inflated. Yes, I agree. Something like that will happen. Ankit, we can take a snapshot of instance in one region, correct? Use that snapshot to create new instance. Yes. The only one step you missed is that you have to copy the snapshot from region 1 to region 2. Okay, Ankit? So you create a snapshot in region 1, then you copy it over to region 2. Then from that snapshot, you can create a new instance. Okay, just give me a second. And third, we can also publicly share, or we can share the snapshot with another AWS user or to the public at large. So in the same way that we can share AMIs, we can also share snapshots. Okay, now let me just show you one thing. So um, Ankit, so Ankit was talking about creating an image from a snapshot. Okay, so let me just show you how that can be done. So these are my snapshots. I'm just going to delete all of them. Okay, so I can't delete two of them. That's fine because they are in use. They are in use by another AMI. Can a snapshot be of any use to world outside AWS? Yeah, let's come to that. But so let's um, yeah. So let me just go to my instances. Okay, and my instance is I just want to check which volume it is using. So it's using this volume that ends with 396T. So I'm going to snapshot that one. Okay. So this is the second one in this list is the volume that I'm going to snapshot. Okay, and I'm just going to call it move to. So I'm going to move it to Singapore. Okay. So I just go to my snapshots list. My snapshot is being created. Now once it's created, this one. So okay, this snapshot, this snapshot is being created now. So there's this copy snapshot uh, link. Okay, so what did I do? I right click. I did right click on the snapshot, and then I click on copy snapshot. So I'm going to copy it to Singapore. But it's going to take a lot of time. It will take at least I think tens of minutes. So but that's fine. We'll just copy it, and in a new page, let me open Singapore in a new page. Okay, so it's being copied. After it will be copied, let's look at what will happen. So this is again, I'm back in North Virginia, but there's an option to create image from snapshot and create volume from snapshot. So I can use these two options to create either a volume or an image from my snapshot. Okay, does that make sense, guys? So there's a practice assignment on this that all of you should do to make sure that you do it on your own, because believe me, when I'm showing it to you, it will not make as much sense as when you do it yourself. Okay, Abhi, what is create image from snapshot? So Abhi, this will create the AMI, Amazon Machine image that can be used to launch an EC2 instance. That is essentially that new EC2 instance will be exactly like the EC2 instance I had when I took the snapshot. Okay, but note that if my EC2 instance had uh, let's say 2 volumes, but I'm snapshotting only 1 volume, then the AMI will have only 1 volume, right? And because snapshots happen on a volume and not on a EC2, so snapshots happen on a volume and not on an EC2. So because of that, if I snapshot only the root volume of an EC2 instance, and then from that snapshot I create a AMI, and then from that AMI I create an EC2 instance. That new EC2 instance will have this 1 volume. So these are the things I think you can also try out on your own. Create image from snapshot equal to create volume from snapshot. No, I mean that's not. Create image will create an AMI. That AMI can be used to launch an instance whenever we want. Okay, guys, let me just check where we are. Yeah, I think we just have another couple of slides on EMS. Let's do that, and then we can take a break. I think I'll go a little quicker. So here are some best practices for snapshots. So because snapshots are point-in-time copies of the data, we have to make sure that that point-in-time copy is a consistent copy. So, for example, if we are writing, some set of data to the volume, and I take and let's say that data is whatever, it could be a database operation, or it could be a file, right? So if I take a snapshot in the middle of that operation, then it won't be consistent. So to get consistent snapshots, ideally, either we should have this idle period on the volume where no data is being written, or if we cannot guarantee an idle period, it is better to unmount the volume and then do a snapshot. Okay, and if we are trying to snapshot EBS root volume, it is we should stop the instance before taking the snapshot. In fact, I think what may happen with the snapshot that we just took, uh, I think we may find that when we create an image out of our snapshot, we may not be able to boot up the instance because it will not be consistent. Because I don't know if you remember, but in class number 2 we saw that I had created a AMI from a running EC2 instance, and then from that AMI created another EC2 instance, and that EC2 instance was not booting up. But when we stopped our first EC2 instance and then created an AMI, then that AMI worked. Do you remember that example? So these are the two things we had tried. So number one, we had tried running EC2 create AMI, and then second one stop EC2 and then create AMI. So, and what the hell am I talking about? I'll just show you. So we go to instances tab on the AWS console, and when I right click an instance, there is create image. So this is what I'm talking about. Okay, when I right click an instance, I can do create image. Now I had done this in two ways. One, I had taken a running EC2 and then done create image. Second case, I had stopped the EC2 and then created the image. In the first case, that these I had used these images to create new EC2 instances. Now in the first case, the new EC2 instance did not boot up, and I think if we snapshot a root volume while the EC2 instance has snapshot, I think we'll see the same thing, that the instance from that AMI will not boot up. Is this making sense, or am I going too far? Do you want me to show you all these things, or I'm hoping that you can try out some. But do you remember this create AMI? Both with create AMI and also create snapshot and then create AMI from snapshot. So as a best practice, if you are snapshotting a volume and if you can't guarantee an idle period, unmount it before taking the snapshot, especially if you want consistent snapshot. And for root volume, you do want consistent snapshot. So for root volumes, it's best to stop the instance before taking the snapshot. Just quickly about the EBS performance. So EBS is optimized for high performance, and it can give up to 80 megabytes per second of sequential IO access and about 100 IO for a random request. But what what's more important, I think, from a performance point of view, is provisioned IO. Yes, Abhi. So if you want consistent snapshots of an EC2, consistent snapshots of a root volume, or anything, if you want consistent application consistent snapshots, like let's say if you're talking about a database and that database is in the middle of writing a transaction to disk, right? So if that transaction will, let's say it could consist of 10 writes to the disk. So if you take a snapshot in the middle of those 10 writes, it will not be consistent. So if you want application consistent snapshots, they are disruptive. So with databases, what you have to do is you can pause the database. So there are these commands in databases like MySQL and Postgres to pause the database and then take a snapshot. It's not really a question of data loss. I think it's a question of data consistency, because you wanted to write a transaction that was made out of 10 writes, but after the third write you have taken a snapshot. So you only have part of the transaction, and a transaction is some of you may know a transaction has this property that is all or nothing. So the meaning of a database transaction is that the whole thing makes it to the disk or nothing makes it to the disk. So if a part of a transaction makes it to the disk, it is very bad. It is wrong, and that's like it's actually a database corruption in that case. Okay, but quickly want to okay, do you guys want to take a break, because I think we've been talking for a long time. Okay, So let's take a quick 5 minute break and come back after that. Okay, 5 minutes, no more. See you guys. Yeah, hi guys. I'm back. So I hope you can still hear me in my webcam and see the shared desktop. And we'll just get started in a minute or so. So Aditya, how do I find out the volume ID that the EC2 instance is using so that I can create a snapshot? Okay. I think there are two ways of doing it. I think we can do it either from the EC2 console or we can do it from the volume console. So let's just have a look. Right. So let me go. So this is the EC2 console instances, right? Okay, actually not the EC2 instances tab on the console. So and I just select an instance, and below you'll see this root devices and block devices. You see these /dev SDA1. So this is a link. Just click on it, and it will tell you the type of volume it is, and as well as the ID and other details like the settings, delete on termination, or the status and so on. Okay, so this is the ID. So this is from the instances tab. Now let's look at the volumes tab. Right. So here we can see that it's basically listing the volume. Firstly, we can look at the state and see which volumes are available, which are in use, and I can click on the. I'll just click on the second one, and this is telling me that it's attached to this instance ID. So basically, from the volume, I can check which instance it is attached to, and from the instance I can check the I can get the volume IDs attached to that instance. Okay. Okay, guys. I think it's so we've had a 8 minute break approximately. So we'll just get started. Can whoever is there, can you just type something on the chat? Just type yeah, YFA, which stands for yes for attendance. Yeah, Ditya. Tell, shoot. Okay, and let me just check. So all of you have to type something. So I want to make sure if all of you are here. So Abhi is here. Abhijit is here. Aditya is here. Ankit, I'm waiting for you. Hidayat, Priyaranjan is here. Rajendran is here. Okay. So Ankit and Hidayat, I'm waiting for you guys. Ankit is here. Hidayat, are you here? Can you type something? Okay. Uh, I'll check on that later. So Aditya, uh, moving to a different zone. What do you mean by zone? It's either a region or a availability zone. So do you mean an availability zone? Yes. Okay. So you cannot move in EBS. Okay. First of all, let me. So the question that Aditya is asking is I think you are asking how to move an EBS to a different availability zone, right? Okay, so I don't think there's a way to directly move an EBS to a different availability zone. You have to do it using a snapshot. So the sequence is take snapshot. I'll just type it out. So create snapshot, then create volume in the different availability zone. Okay, if you want, we can quickly have a look. So we have the snapshots which are just loading up. Now let's say snap 1. I want to create a volume from the snapshot. It'll ask me for the availability zone while creating the volume. Okay, so that's how we can select that the new volume will be in what availability zone. Okay, the same will be for an EC2 instance as well. Aditya, what do you mean by that? I didn't quite understand the question. So what are you doing with that EC2 instance? Are you saying moving an EC2 instance? Okay. Moving, I think can be done. Okay, no. So moving also cannot be done directly, but we can just check it. Yeah, I'm just checking something. Just give me a second. Yeah. So there's another way to do it. Okay. So yeah. So what you are saying can be done, but see, remember, snapshot is on a volume level. So if your EC2 has, let's say, 4 EBS volumes attached to it, then it's not that easy to, you can't just do it using a single snapshot, basically. So better way to do that is stop your. Hang on, 1 second. So so there are a couple of ways to do this. One, you can do launch mode like this, but no, again, so Aditya, if you create a snapshot, you'll create a snapshot on how many volumes? Just one, right? And then your AMI will have just that one volume. It won't have the other 3. So that's the problem. If your EC2 has multiple volumes, you can't you can't move it by just creating a snapshot and then creating an AMI and launching it. You have to do something little better, because basically the problem is that snapshot work at the volume level, or work on a volume, whereas what you want when you're moving an EC2, you want something that works on a complete EC2. Yeah, if you have 4 snapshots, but there's no way to create. So I don't think there's a way to create any AMI from 4 snapshots. Actually, there might be. So what we can do when we are creating. Let me just show this. So so when we are creating an AMI, we can also add more volume to that AMI. So let's say I have snap 1. From snap 1, I'm going to create image. Okay, so I hope everyone can see that. Now, yeah, something like that. So this image, what I can do, I here I can add more volumes to this AMI. So basically, at the time I'm creating an AMI, I can add more volumes, and uh, these volumes can come from a snapshot. So in your case, what you're saying, yeah, we can create 4 snapshots for those 4 different volumes. Then we can create an AMI that has you know that has one root volume from one of those snapshots, and then 3 other EBS volumes from the other 3 snapshots. So that will work, but it is a little, it may be a little more tedious. Instead, another way to do it would be, so you go to instances, and then from instance you create uh, image directly from the instance. Okay, so this by default it will already list the all the volumes that are attached to the instance. So you don't have to add every, you don't have to go to the pain of creating 4 different snapshots and then 4 different volumes in the AMI, because when you do create image from EC2, that will already list all the volumes that are attached to that EC2. So guys, I don't know. I hope you were with what we were discussing. So Aditya had basically asked the question of how do we move and EC2 instance to a different availability zone. And what I'm suggesting is that a better way to do it would be to create image from the EC2 instance, then use that image to launch a new instance in the different region. So did that make sense? And anybody lost? Okay, so I think Aditya got it, but what about the others? Can can someone volunteer to explain how can we move EC2 instance to another availability zone? So anyone except Aditya, can one of you volunteer? Okay, create an image. See, now there are 2 ways to create an image. We can create an image from a snapshot, or we can create an image from an EC2. Okay, Abhi Rajendran, create an image from where? Create image from. Yeah, so if you create an image from snapshot, the problem is that what if your EC2 machine had 4 volumes? Okay, but snapshot works only at a single volume level. Amazon doesn't have any way to take snapshot across 4 volumes. Okay, so that kind of thing doesn't exist. So the question is that should also have 4 volumes. So how do we do that? So this is what I was saying. So let's create an image from the EC2 instance itself. So image, instance, and snapshot volume. Yeah, Abhijit, I'm not exactly sure what you're saying, but these concepts are kind of tied together. This image or AMI, EC2 instances, snapshot volume. So I can create an AMI from either a snapshot or from an EC2 instance. So both are possible. But the point you have to understand is like in this case there could be multiple volumes on the EC2 instance. So if I create a AMI just from one snapshot, that will cover only one volume. What about the other three volumes, right? So then there's a way when we are creating an AMI, there's a way to add more volumes. So that can be done, but it involves more steps and it's prone to error. So instead, a better way is just to create an image from the EC2 instance itself, and then use that image to launch a new instance in the different region. Okay, so what I'll do, I think we've discussed a lot of very interesting questions around the snapshot images and things like that. I'm going to create some practice questions and assignments based on this to make sure that you get hands-on practice on these things, because only then you will actually when you try out these different kind of scenarios on your own, uh, you'll get a good sense of things. And since we are talking about that, I want to share something with you. I know we are deviating a little bit, but this is something that I was planning to share towards the end of this class. But let me just share it right now. So I think a great way to learn, especially something like AWS, is to ask questions like this. Ask ops questions like, how do I move this EC2 instance to another region or to another availability zone? How do I create a new volume? Some ops related questions. So I want to show you two sites which so okay, let these sites just show up. So these are actually two applications. One is called Cloudy Scripts. So this Cloudy Scripts is basically a small tool that automates some of these common use cases or operations in the context of AWS. So for example, they have automated the copying an AMI to a different region, converting an instance store AMI to a EBS booted AMI. So we've not really discussed some of it, but that's fine. Downloading a snapshot as a zip file, copying a snapshot to a different region. So basically, they have there's this list of common operations, and we can go and let's say as a AWS user, I can go and execute this operation on Cloudy Scripts for my AWS account. And there's another kind of similar one called Schedly. So Schedly has also automated some of these common operations. For example, starting an instance, stopping an instance, launching an instance. Then maybe some of the more complicated one, like let's say growing an EBS volume, copying an EBS volume to some place, copying EBS snapshot, and so on. So one of the things I was thinking is that I would like you guys, as part of an assignment, you can take up some of these common operations and write your own, let's say a CLI script to perform that operation. So these are obviously web applications, but we are not kind of doing web application in this course. So, but you can take some of these operations and then write a script, a small script that uses, that can either use AWS CLI or it can use AWS APIs to automate that task, right? And these two are actually web applications. They are actually companies who have built a a sustainable small business around automating some of these common tasks in AWS. Yes, so Aditya, CLI we are going to do in the next class, and API is kind of little on the periphery for this course. But API we will just be doing a I'll be doing a quick demo or a very quick introduction of APIs in the last class. But CLI definitely we'll see different kind of the CLIs for EC2, EBS, also auto scaling, RTS, and so on in the next class. And yeah, we'll do a demo of that. Okay, but just think of this. I would like if possible visit these sites. These are I think both of these are very cool applications and useful applications for automating common tasks in AWS, and you can build your own scripts to automate some of these tasks as an assignment. Okay, so with that, let me please move on, because actually I'm again running badly behind time, so I'm just gonna try and rush a little bit. So provision IOPS. So the main idea of provision IOPS is to deliver a consistently high performance for IO intensive workloads hosted on EBS volumes. So we've seen that EBS volumes have on the previous slide we said that they have about 100 to 200 IOPS per second, but what we can also do is that we can use this feature called provision IOPS, and when I'm creating an EBS volume, I can specify an IOPS rate for that volume that I need, and Amazon will try to deliver that specified performance over the lifetime of that volume. And we can specify a maximum of 4,000 IOPS per provisioned IOPS volume, and we can have a maximum ratio of 30:1 between the IOPS and volume size. So which basically means if my volume size is, let's say, 100 GB, I can have 30 into 100, which is 3,000. I can have maximum of 3,000 IOPS for that volume. And essentially, how does Amazon does this? If I specify a provision IOPS volume, it'll put that volume on a type of it'll choose the type of disk suitably. So for example, if I want it could choose SSD disk for very high number of IOPS, or it could choose dedicated SATA disks. If I want let's say maybe around 500 to 1,000, it could it could use the dedicated disk. So those kind of decisions AWS makes when a user creates a provisioned IOPS volume. Okay, and let's just quickly see how to do this, how to use this feature. It's very easy from the console. So I'm just going to create a new volume from. So I've gone to the volumes section, and then I'm going to create a volume. Okay, so volume type. Volume type can either be standard or provisioned IOPS. Okay, so standard is basically what IOPS will get. Will get basically the basic EBS. Then we use let's say we'll use provisioned IOPS. So let's say I want 100 GB, and we've seen that the maximum is 3,000. For 100 GB, the maximum is 3,000 IOPS. But let's say I do 4,000, and I can specify the availability zone, no snapshot. Then I say create. It's saying that maximum ratio 30:1. So what I can do, I'll do 1,000, and then I'll say create, and this will work. Okay, so basically the one second. Yeah. So the idea of provision IOPS is to you use it in places where you need consistently high performance. So for example, a database. If you're using an EBS volume for a database and you need good performance from your database, use provision IOPS, and then you can also select what level of performance you need. Maybe Ankit. Although it depends on the latency is for the AWS console app, and I'm not sure where that is hosted. Okay, so is this clear? Provision IOPS, and let's just look at the pricing for EBS. So we saw that instance store volumes are basically included in the price of EC2, but EBS volumes have separate price, which is uh, 10 cents per gigabyte per month of the provision storage. So basically, it means that and this was standard volume. So if I have a standard volume of 100 gigabytes, and so it's that volume is going to charge me $10 per month. Okay, and if I use that 100 gigabyte volume only for half a month, it's going to cost me $5. Basically, all that is pro rata. Make sense? But additionally, there's this the pricing for standard volume is complicated because Amazon also in addition to the storage capacity, Amazon also charges you for the number of IO requests you make to that volume, and they charge what 10 cents per 1 million IO requests. But normally, the first part of the cost, the first part of the price, which is the amount of storage, will dominate. Okay, so just roughly remember that it's 10 cents per gigabyte per month for standard volumes. Now for provision IOPS volume, it's a little different, the pricing. So the pricing is 12.5 cents per gigabyte per month per GB. Yeah, 12.5 cents per gigabyte per month plus 10 cents uh, per provision IOPS per month. One second. Yeah. So if I'm using 100 gigabyte volume with provisioned IOPS of 1000 IOPS, so it will cost me 100 into 12.5 cents, which is $12.5 per month, plus it will cost me 1000 IOPS into 10 cents, which is $100. Okay, so in this case, the cost for the IOPS can be significant. And just to okay, so actually that's fine. So this is a self-practice assignment that I wanted you guys to do to just understand this performance of EBS standard volume and provision IOPS volume. So basically, you have to create an EC2 instance with one EBS standard volume and one EBS provision IOPS volume, and then measure the performance of both of these volumes with the FIO tool, which is available on both Windows and Linux. So this in this I've shown the Linux variant of the command, and whenever we are measuring storage performance, the key thing always is what is the workload for which we are measuring performance, and typically there is this there's this broad categorization whether it's a sequential workload or a random workload. The sequential workload is something like you have a large file, you're either reading or writing a large file. But a random workload in sequence, from block 0 to block 1 to block 2 and so on. Whereas a random workload is I have this large file, but I'm picking a block at random from the file and reading or writing to it, and the performance can be very different for different workloads. So you can try out of there are these 4 workloads, all of which are supported by FIO. So read means sequential read, write means sequential write, rand read means random read, and rand write means random write. So you can do this self practice assignment and share the results with me, and I'll be happy to discuss it. Now there's another assignment I was thinking about, but which I've not actually mentioned here, is was that it was around the pricing that beyond what level of IOPS. So let's say I have 100 gigabyte volume, okay, and through some experiments I know what is the kind of IOPS requirement I have from my volume. Now beyond what, so let's say that IOPS level is n. So the question was that for what level of n is it better to use standard volume versus provisioned IOPS volumes? So I'll put that question also in these slides, and if you want you can look at it. But key takeaway is that standard volumes cost about EBS cost about 10 cents per gigabyte per month. But if you're going to use if you're going to make a lot of IOs to your EBS volume, there may be a significant price also for the IOs that you have to pay, which is 10 cents per 1 million IO requests. And if you don't want that kind of headache, you can go for provisioned IOPS and just pay. You can just say that I want 100 IOPS on my volume, and then you don't have to pay this variable price on number of 1 million IO requests. You can just say 100 IOPS into 10 cents, which is $10 a month for the provisioned IOPS. Yeah, but in general, provisioned IOPS volumes are great if you have IO intensive workloads that need fast and high performance storage. At least I want to make sure that all of you got that point, because you in your work you may have to decide what kind of volume to use for hosting these applications. So you should be able to make a decided you should be able to make a careful and analyzed decision on whether to use standard EBS or provisioned IOPS. And if you're using provisioned IOPS, what level of IOPS are you going to provision? Are you going to provision 100 or are you going to provision 1000? So to know that, you have to know what is the performance expectation from your application, or sorry, performance expectation from your storage. Okay, so with that we're done with EBS. So any questions from EBS? Is this making sense to you guys? Can we not configure IOPS to scale as per load? So okay, that's an interesting question. Let's just so see the thing, one part of the answer is that Amazon will not do it for you, right? So Amazon will not monitor the load for you and scale up the volume change the volume type based on what performance you need, because Amazon doesn't know what performance you need, right? So as a systems administrator, we have to at least figure out what are the requirements from our storage. Yeah, but still, basically Amazon doesn't know what are your requirements. So as a either as an application engineer or a systems administrator, we have to be in a position to tell what are our requirements in terms of performance from our storage, and we basically tell that in terms of the number of IOPS we provision on the volume. And the question, how do we how do we figure out what our requirements are? So Amazon has a tool called CloudWatch that can help in that regard, that we'll talk about in the next class. So basically what happens is that if your volume is too heavily loaded, so let's say for example your volume is provisioned for 100 IOPS, but you're getting much more load on that volume. What will happen is that the latency for every request will begin to increase, and you can monitor that latency, and if it begins to increase beyond a certain point, you know that your storage is becoming the bottleneck, and then you can do something about it. You can increase the provision IOPS on that volume. But we'll see in the next class of how we can use this tool called CloudWatch to monitor performance of EC2, EBS, and so on. Okay, but let's but I just want to get some feedback from you guys. Is this at least in terms of the basic stuff, is this making sense? What is EBS? What is provision IOPS? Why do we have provision IOPS? What are snapshots? What are some of the common use cases for snapshots? At least at a basic level, are you able to understand these concepts? Yes, provision IOPS is a kind of quality of service guarantee from Amazon. So okay, I'm not hearing from you guys, so I'm just a little afraid that I may have lost some of you. Yeah, so that's a question, Rajendra, very good question. That's a question I also had. I'm not sure. We can just try it out. I doubt if it can be done, but let's try it out. So this middle, I'm going to select this middle volume, which has 1000 IOPS provision on it. Okay, and yeah, so at least from the console, there's no way to change it, right? So again, for this, we'll have to do the snapshot thing. We'll have to create a snapshot from this volume. Then from the snapshot, we'll have to create another volume with a different provisioned IOPS setting. We can't change provisioned IOPS directly on the volume. Make sense? Did you understand how we can do it using snapshot? Okay, good. Okay, Ankit, thanks for the feedback. So I'll try to focus less on the pricing. Okay, let's continue. But at least we need to have at least a basic level of understanding about pricing also, because that is if you're going to be consulting to your clients or to somebody, whoever is paying for this service, the pricing will be very relevant. Okay, Abhi, and then detach. Yes, exactly. So of course we have to detach the old volume and then attach the new one, right? So actually that's a good. So guys, I want to ask everyone. So Rajendran asked this great question, that can the provision IOP setting be changed dynamically on a volume? And my answer was no, it can't be done directly on a volume, but we can do it using snapshots. So did all of you understand how we can do it using snapshots? Or who is there anybody who did not understand how we can use snapshots to change the provision IOPS setting on a volume? So I think Abhi, Aditya, Rajendran, I think you guys got it. Ankit, Priyaranjan, Ankit, Priyaranjan, and Abhijit. Any? Can you guys describe to me how we can do it? What are the steps? In fact, I'm gonna make this a. I would like to make this a self practice question, but I'm you know I'm not very sure of whether you guys will actually do self practice questions. So should I make this an assignment question? Are you guys up for that? Unless you guys try out these things on your own, you will not really understand what's happening. So you have to try out these you have to kind of do it with your own hands. You have to spend some time to play around with these things. So should I make this Rajendran's question assignment for you guys? Okay, great, Ankit. Thank you. Okay, so let's. Can we? I'm really behind on time on this course. Can I take it around 10-15 minutes to cover S3, because there was another module that I wanted to cover called RDS, which we will not be able to get to. But can we at least finish S3 today? And I'll try to speed up through it. Okay, so S3 stands for Simple Storage Service. Now, so S3 is very highly scalable and durable data storage. So durability is a reflection of what is the chance of the data getting lost, and availability the refers to how what is the chances that the data is not accessible. Okay, so durability is what is the chances that the data gets lost. Availability is what is the chances that the data is not accessible. So S3 has very high durability and availability. It has 11 nines durability, which is like 99.99%, and 4 nines availability. So 4 nines availability, I think this means that your data will be unavailable only for maximum around 55 minutes in 1 year. So that's the kind of claim or guarantee that Amazon is making to you. This data is replicated within a region and across availability zones. So remember, EBS data is replicated only within an availability zone, and that's why EBS has lower durability and availability compared to S3. Okay, S3 has more replication, so because of that, more durability and availability. And because it's replicated across multiple availability zones, S3 can sustain S3 is actually replicated in 3 availability zones, so it can sustain the concurrent loss of 2 facilities. So because it's there in 3 places, 3 availability zones, even if 2 zones out of that are lost, the third one will be able to serve the data. So that's the very high level of guarantee that we're getting. So it's highly scalable, which means we can store very large, almost like unlimited number of objects in S3, and it's also very highly scalable in terms of performance. We can make millions of requests, concurrent requests to S3, and it will be able to serve that. And we can read, write, delete files from one, up to 5 terabyte basically. And S3 is something called object storage, which we'll talk about later. Now, one thing about S3, which is very different from EBS and Instance Store, is that EBS and Instance Store were attached to a particular EC2 instance. Okay, S3 is not like that. S3 is kind of it's a managed storage service provided by AWS. So which means that if I'm storing some data in S3, I don't have to worry about the servers, the compute resources and all that to serve that data. All that is taken care of by AWS. So for example, think like many of you must be using Dropbox. So when you're using Dropbox, you don't have to worry about the compute resources. So when you're using Dropbox, you don't have to worry about the compute resources that Dropbox needs to serve that data for you. So similarly, Amazon is responsible for, in the context of S3, it is responsible for both the storage and also serving that storage to you or to the user. Right? So I hope that difference is clear. In EBS and Instance Store, it is us. We are responsible for the compute resources to serve data stored on the EBS and Instance Store. But with S3, Amazon itself has a compute resources that will serve that data. Okay, now I want to quickly talk about object store. Oh, okay, we'll talk about object store next slide. Now S3 uses statistics. So let me just give you an example of some of the mind-boggling statistics about S3. So today S3 stores more than 2 trillion objects, and just try to count the number of zeros in there. There are 12 zeros. 2 trillion objects, and over 4 billion objects get added per day. So 4 billion, and which translates to roughly 40,000 new objects per second. So that's the kind of scale that S3 can handle, and is already handling today. And another interesting thing is that S3 is often used as a benchmark for the growth of AWS, because AWS is, and Amazon and AWS in general, they are quite they don't reveal their usage statistics too much. So for example, they'll not tell you how many EC2 instances are being used in Amazon. They'll not tell you how many physical servers they have. So they are kind of secretive about that. But one figure they happily share is the number of objects in S3, and because of that, over the last several years, the number of objects stored in S3 and being served from S3 is used as a very good benchmark for AWS growth. Okay, I hope you understand what I was trying to say. So for example, if today S3 is storing 2 trillion objects, and after 1 year storing, let's say, 4 trillion objects, we can say that AWS has grown 100% in 1 year. So that's the kind of thing. So that just That's the kind of growth. That's how we can use S3 as a benchmark for AWS growth. Okay, now want to talk about object storage. It's a big topic, but I'm just going to try and shrink it to a bare, basic fundamental understanding. So, object storage is first of all not block storage. So it's not like a hard disk. When you think of object storage, think of something like Dropbox or Google Docs, or maybe even something like SharePoint. If you guys are familiar with SharePoint, so those are something similar to what is object storage. The concept of object storage. So object storage is typically accessed via a REST API over HTTP, and not via a block interface. Secondly, an object. What's the definition of an object? An object is a combination of data plus metadata. So the data is the content of the file plus metadata. So for example, metadata includes file system metadata. For example, any file system will have things like what is the size of the file, what is the name of the file, what is the creation time or last update time of the file, what are the permissions of the file, things like that. So an object has all of those kind of metadata, plus it can also have user defined metadata. So I can say that, for example, one of the examples I commonly give is I have a bunch of photos that I'm going to store. I can tag my photos saying that these are my photos from my trip to Goa or my vacation to Goa last year, and these are my photos from my workplace, so on. And so basically we can have user defined metadata, and that user defined metadata, as Abhijit is suggesting, can be used for searching the object plus doing a lot of other things. But basically we can have user defined metadata on an object. Then objects have a unique identifier called the object ID. We'll see this in the context of S3. Okay, the next point is very important. In a block storage, access is done at a block level. The block could be 4 kilobytes or 8 kilobytes or 16 kilobytes depending on the file system, but it's done in fixed block sizes. However, in object storage, we typically access the object as a whole. So we download the whole file or we upload the whole file, things like that. So it's more like these are web-like usage patterns rather than disk-like. And last point, again very important. So object storage is S3 especially is shared storage. So a block device can only be attached to a single controlling device at any point in time, but with S3 you can have hundreds or thousands of devices accessing the same S3, the same data in S3 concurrently. So S3 is shared storage versus EBS and local instance store are dedicated to a specific EC2. Okay, what are the use cases for S3? So static web content. So things like images, videos, any website that has these contents like images, videos, JavaScript files, CSS files, static HTML files. So things like that. A big use case is backup, archival, and DR. So DR means disaster recovery. So a very common thing today is that all of these backup softwares, like Symantec, IBM, things like that, they have integrated with S3. So they provide you an option to back up your data to S3. So they have this connector service that will back up your data to S3. And why to S3? Because of the very high durability. Because you want your backups to be, you don't want to lose your backups. because if you lose your backups and if you've also lost your primary copy of the data, you're done. You're dead basically. And because of the reasonable cost, which we'll see again, it's roughly around 10 cents per gigabyte per month. And it's also used for working storage for large scale computation for analytics. We'll just not go into detail of this, but the first two are important to understand. From a introduction to AWS course, you should understand what is static web content, and how we can use S3 for that, and how we can use S3 for backup and archival use cases. Okay, so S3 data is organized into buckets and objects. A bucket name has to be unique across entire AWS, and every object has a unique URL across all of AWS. Objects can be either a file or directory, and so on. And object support access control list. We will see these things in a demo. S3 features. S3 supports something called versioning. Versioning means that, so let's say you're working on a Word document. You save it every 1 hour or something. So you're basically creating multiple versions of that Word document. So if you're storing that document in S3 and if you enable versioning on your bucket, S3 will store every version of your document so that you can go and look at the history basically. Then S3 support encryption. So if you enable encryption, all your data will be stored in an encrypted format in Amazon's servers. Then access control, we can control access to objects. We can give access only to specific AWS users, or we can make it public or private only to us. Then it also supports something called data lifecycle management, which is we will talk about Glacier. We can automatically archive data to Glacier. So, for example, in backup, let's say my semantic backup software is taking daily backups, but as an organization, what I decide is that any backups older than 30 days can be archived, and archive basically means that I have a very low chance of accessing them ever again, but I do want to store it. I don't want to delete it yet. So for that, there's a special form of S3 called Glacier, which is 10 times cheaper than S3. So S3 is about 10 cents per gigabyte, but Glacier is only 1 cent per gigabyte per month. And basically Glacier can be used for archival, and automatic archival means I can say that any objects that are older than 1 month are automatically archived to Glacier. So from S3 they go to, so the workflow is that from semantics creates the backup, stores it in S3, then those backups are in S3 for 1 month. After 1 month they go to Glacier, which is much cheaper. Then we can schedule deletions. So let's say when a backup has been 1 year old, then as a company I decide I don't need that backup anymore, so I'm just going to delete it automatically. So I can say that any backup older than 1 year, delete it automatically. So those things I can do. Okay, the price roughly, it's about 9.5 cents per gigabyte per month, but it reduces with the the more amount of data you use, the price per gigabyte reduces accordingly. Important thing to note is that access to data is priced separately. Roughly it's about 10 cents per gigabyte, but it's only for download. So Amazon has this interesting thing. When you upload data to Amazon, they don't charge you anything, but when you download data from Amazon, they charge you approximately 10 cents per gigabyte. Okay, reduced redundancy storage is a type of S3 where the data, where objects are replicated a little less. So in S3 they are replicated in 3 availability zones, whereas in RRS they are replicated in 2 availability zones. So it has a slightly lower level of durability and availability, which is 4.9. So instead of 11.9 durability, it has 4.9. and objects are replicated within an availability zone. And actually, it should be objects are replicated in 2 availability zones, and because of that, it can sustain the loss of data in a single availability zone, and it has a slightly lower price. So instead of 9.5 cents per gigabyte per month, it's 7.6 cents. The Glacier. So Glacier is very interesting. It was not, I think, just so S3 has been around for a very long time. S3 was one of the earliest services started by AWS, but Glacier was started, I think, in 2011 or 12, and the use case is very targeted, very simple. It's basically extremely low cost storage for data archival. And archival, again to repeat, this is the kind of data that I don't expect to access. I don't expect to access frequently, or actually I don't really expect it to access it ever. But I don't want to yet delete it. So this is infrequently accessed data, and Glacier takes advantage of this fact by saying that the retrieval time for data stored in Glacier can be several hours. So in S3, when you want to access data, you just do a get on the object and you'll get the data immediately. But in Glacier, it can take several hours to retrieve the data. But which is because Amazon is maybe storing this on tapes, or maybe storing it on disk, but not keeping not powering on the disk all the time. Maybe they have some kind of a robot where the robot figures out which disk or tape to load, where the data is located, and only then the data is accessible. So because of that, it takes several hours to download the data, but the benefit is that you get much cheaper. It's roughly 1 cent. It's 1 cent per gigabyte per month. Tape would be what? Okay, and it has the same level of durability and availability as S3. So 11 nines durability, 4 nines availability. Okay, here's the self practice assignment. Let's quickly check this out. Okay, so I'm going to go to services. I go to S3, right? I think this will just take a couple of minutes. I just want to give you a very basic demo, and then I would really request you guys to try out the other options like versioning, encryption, things like that. Okay. For now, I'm just going to create a bucket. When creating a bucket, I have to give a unique name. So I'll just say Skillzoo test one. Okay, something, and then I give which region I stored the bucket in. Okay. Now one question for you guys: why do I have to give only the region and not the availability zone? For example, in EC2 and ETL, we saw that we have to give the availability zone also. In S3, I only have to tell which region to store the data in. Anyone? Aditya has answered. I'll come to his answer. But any other volunteers who want to answer this question? Sleeping or bored, or you don't know? Okay, so Aditya and Abhi both are right actually. So basically, Amazon will store the S3 data in 3 availability zones in that region. So it doesn't make sense to say which availability zone I want to store the data in, because it's actually not one availability zone, it's three availability zones, and that Amazon will decide. So I just have to tell the region. That's the reason. And so I'll just create. Okay, there's something called setup logging. Logging is basically it will log every operation made on this bucket. You know, like every get, put, delete, post, everything, so that you can you know, refer to that log at a later time. So if any of you are familiar with the logs for web servers like Apache or Nginx, this log is very similar to that. It basically logs what was the operation made on my S3 bucket. Okay, so I'm going to create it. Okay, now this is my bucket. A bucket is essentially, it's like a repository of data, and this every bucket has a unique URL corresponding to it. Okay, and for now, let's just quickly let me just upload some files. If I can find something. Okay, let me just upload these two screenshots. Let me create a folder. Okay, then let me go into that folder. Let me upload some more files. Okay, so this is my uploads are being done. Now let me see. I want to access this document. So I'll just go to properties on this right side, and this has the unique link. Okay, I'll just open this unique link so you can see. So just look at what the unique link looks like. It has s3.amazonaws.com. This is the you know, the basically the S3 server name. Then after that, it has the bucket. This is my bucket where I'm storing my data, and then the object name, right? And I'll just hit enter. Now here it has given me some. It has not shown me the object. It has given me an error essentially in XML, which is access denied. The reason I'm getting this error is because my object is not public. I'm going to add some permission. So I'm going to say everyone can open or download this file. Okay, so that is done, and I think I should be able to access my object now. Right, so that object is loading. Right. So this was a very quick overview of S3. Now, but basically we can store things like okay. Now wanted to share. So for example, Dropbox. So these services use S3 for storing the data. Dropbox and pretty much any service that has photos, videos, that kind of thing. Like for example, Instagram. I think Instagram will also be using S3 for storing the data. Okay. Now I would like you to try out a couple of self-practice assignments. So for example, create bucket, then add an object to bucket, view the object. So we can also download the object from uh, from the AWS console. Okay, very interesting question from Aditya. Can we mount an S3 bucket to an EC2 instance? So mounting is typically for what kind of devices, or what kind of data sources? It's typically for block devices, or yeah, NFS. NFS is also a block. It appears like an NFS volume appears like a block device to your server. So the answer is that S3 bucket cannot be directly mounted to EC2 instance. Okay, but so that's a basic answer. But some people have developed a way to make S3 appear as a block device using not ISO files. It's something called, I think it's something called S3FS. So I think S3FS. So if you know of something called Fuse, so Fuse is a uh, is a framework where you can write file systems in the user mode, something like that. So yeah, so these guys, S3FS uses Fuse to make S3 appear as a block device uh, to Linux. But so a block device has kind of these operations at the logic level. Get 4 kilobytes from this offset, write 4 kilobytes to this offset. So what this S3FS does is when it traps these operations and then makes the corresponding REST calls to the S3 service. So basically REST calls are like HTTP calls. It makes these HTTP calls like this. 1 second. So like this screenshot. So some of you may have seen that. So when I hit enter on this screenshot, basically the browser does a get on that screenshot, and this is called the HTTP protocol or REST protocol. And basically S3FS will translate your block device operations to REST calls on the S3 API. So if you're interested, you can check it out. But I don't really know. So I know about this project, but I don't really know how what its production quality is and what its performance is and so on. And I don't think it's officially supported by Amazon. It's mostly like an open source project that some people who were interested in using S3 from using S3 as a block device have developed. Okay, the advantage of this is that of course you can do something like your S3 bucket will start appearing like a directory in your file system. Basically, it will start appearing like a mount point in your file system, and then you can copy, move files, create files using regular Linux command tools. Okay. Now quickly, I think that's pretty much what I had for today. But just give me a minute. I just want to check on. I just want to check if so. I think your quiz is not yet up on the learning management system, and I'll also check if I hope because I was also planning to cover something called RDS or relational database service in this class, but we couldn't get to that. So I think I'll let you know about the quiz via email. Beyond that, yeah, any things that any questions or any things that you want to discuss about these topics that we've covered today? Basically, instance the different storage options, EBS, S3, instant store. So EBS and S3 are the more important ones. Instant store has a much less useful, less common use case. But make sure that you've understood EBS, snapshot, S3, those things well, and please do spend some time on practicing these things on your own on the AWS console. So anything, Abhi, Aditya, Ankit, Rajendran, anything else that you guys want to discuss today before we break? Okay, thank you, Rajendran. I'm glad that you liked it. I hope, but remember, I keep emphasizing that this course is not about me, giving presentations to you. This is not valuable. The more value will come when you go and try out things on your own on the AWS console, and when you read the reading material on your own. That will give you a much better level of understanding. Yes, a lot of backlog. So guys, please take it seriously. I'm not very happy with this backlog, and if this cannot continue, if you're not, I need you guys to put in the effort to do these assignments, to basically do these assignments and to go through the reading material that we are covering in this class. So I absolutely need you to put in that effort. That is not an optional part of the course. It is mandatory. It is required. I'm not to be very clear. I'm not going to pass you guys on this course unless I see that you've spent a good amount of effort on your own on the assignments. Okay. So if there's nothing else, let's break for today. Thank you and sorry at the same time for keeping you here for an extended class. We've gone beyond the schedule by 40 minutes. So thank you and apologies for that at the same time. Okay, and then let's keep in touch via the forum or email, and but please do put in your effort, and I'll see you next Saturday now. Okay, we have this one class next weekend on Saturday. Okay, and please do, I'm here to help you. I'm here to guide you. That's my role. So please do feel free to contact me anytime if you have any problems. But if you don't have any problems, I'm assuming things are going well for you, and you will show me assignments 1, 2, 3, and as well as the reading material by next weekend. Okay. Okay, guys, thanks a lot and goodbye. Have a great Sunday, whatever's left of it, and have a great week ahead at work and do your assignments. Thank you very much. Bye.